In example 3, we are going to sketch g at x, which is a transformed cosine function. So I'm going to start off by listing all of my values of a, k, d, and c. Starting off with my a value, it's this one out here. That is my a, is negative 1.5. My k value is 3. My k value there. My value of d is pi over 6. And again, we have to be careful because our original function, or our general function, is x minus d, right? So the x minus is part of the original general formula, so that makes my value of d simply this pi over 6. So just something to be careful of. And finally, my value of c is 0.5, right there. Perfect. So now let's list all of the key features using these transformations. So my amplitude is the absolute value of my a. The absolute value of negative 1.5. Remember, that just takes whatever's on the inside and makes it positive. So we actually have a negative value in here. So these absolute value bars, will turn that into a positive 1.5. So my amplitude is going to be 1.5, not a negative, because an amplitude can't be negative. Next up is our equation of the axis, or our midline, and that is our value of c. And our value of c is 0.5. Now we're going to use these two values to find our maximum and our minimum. We're going to take that midline of 0.5. We're going to add our amplitude, which is why it's so important. That is the absolute value. We're going to add a positive 1.5 to get the maximum. So our maximum here, 0.5 times, 0.5 plus 1.5 is going to be 2. And 0.5 minus 1.5 is going to equal 1. So yeah, it's going to be equal to negative 1. All right. Next up is the period, or the length of one cycle. As we take my 2 pi and we divide it by my k value, and my k value was 3. That means one cycle is going to be a length of 2 pi over 3. Now to find the distance between each critical point, I'm going to take the value of our period. We're going to take that 2 pi over 3. And we are going to divide it evenly by 4, which will turn into 2 pi over 12, or when we reduce that, I have pi over 6. So let's take a look at how I got that. I'll do that down here. 2 pi divided by 3, all divided by 4. Okay, so we're deciding how this turns into 2 pi over 12. So I can rewrite this division statement, 2 pi over 3 divided by 4. It's the same thing, just a different division symbol. Okay, and now I've got a fraction divided by something, and I don't like dividing fractions. So we're going to turn this into a multiplication. Because this is 4 over 1, because every whole number is always over an invisible 1, we are going to flip that second value. This is going to be 2 pi over 3, but now we are multiplying by 1 over 4. And when we multiply fractions, we multiply the tops multiply the bottoms. 2 pi times 1 is just 2 pi. And 3 times 4 gives me 12. So that's how 2 pi over 3 all divided by 4 is equal to 2 pi over 12, which we reduced down to pi over 6. So now I can use this and know that every critical point is spaced out by a distance of pi over 6. But now let's move into our critical points. So I'm always going to be starting on my value of d. My value of d is also pi over 6. So that's where I'm going to be starting. For my second critical point, I'm going to go from that original pi over 6, and I'm going to add the distance between each critical point, which is this pi over 6. So this is why I like to use my colors so you can see where things are coming from. Okay, so when I add those two together, that's going to give me 2 pi over 6. I'm lucky because my denominators were already the same. I'm going to hold on to that value of 2 pi over 6. I'm going to take that. I'm not going to reduce it quite yet. You'll see why, because it'll be easier to add. I got to take that 2 pi over 6 and add another pi over 6 because all of these critical points are spaced evenly apart. When I add those two together, 2 plus 1 gives me 3 pi over 6. And I take that 3 pi down here, 3 pi over 6. I add another pi over 6. Okay, so that's the 3 pi's. That's the 1 pi. That matched from right there. And what are we adding to now? Now we are at 4 pi over 6. I've got one last critical point, 4 pi over 6, plus another pi over 6. So where does that leave us now? Well, that means my fifth critical point will be at 5 pi over 6. Not bad at all. Okay, we are almost there. So let's start to see what we can sketch out. Well, my maximum is 2 and my minimum is 1. So let's make that, negative 1. Make that 1, 2. We'll make this negative 1 and negative 2. And I'm dealing with some pi over 6s, right? So this is pi over 2. That would make this in the middle here pi over 4. So then pi over 6 is probably about here. And then pi over 3 would have been about there. Okay, so I think we're going to need that going forward. So I think that's everything we need now to sketch in some of our key features here. So my midline is at 0.5. Let's use the right color here. Mine's at 0.5, which is about that. My maximum is at 2. And my minimum is at negative 1. So we are an amplitude of 1.5 apart, right? There's 0.5 and 1, 0.5 and 1. Perfect. So let's make these dotted lines as we usually do. All right, just about there. Cool. So again, this was my max, my midline, and my minimum. Awesome. Next up, I need to try and figure out what this is going to look like. So what shape this is going to be. So I'm dealing with a cosine curve, okay, which typically we've seen so far to be something like that, right? But we've got a little bit of a change here because my a value is negative. And if you remember from our transformations of quadratics, the negative a value is a reflection. It's a reflection over the x-axis. So because it is a negative cos, this is going to be flipped. So it's actually going to look like that. So that is something to be very careful of as well, because the amplitude matters. The sign of the original a value matters. So this is what we're going to be dealing with here. So I'm going to have my first critical point. I'll do my colors. My first critical point is going to be here. My second is going to be here. My third, fourth, and fifth. So this is a little bit different than the last example, right? My first critical point is instead going to be at my minimum, okay, instead of my maximum, because my a value is in fact negative. Okay, so now we can use our coordinates of our critical points and where they will be on our grid to sketch this function. So my first critical point is going to be at pi over 6, and that will in fact be at my minimum. So pi over 6 is here. It makes my first critical point. I'll do it in red because now we're dealing with a negative. Pi over 6 at my minimum. We are right here. That's my first critical point. Red. My second critical point is at my midline. And my second critical point is this. So I can now reduce this to make it a little bit easier. 2 pi over 6 is actually going to be pi over 3. So pi over 3 is my next one, and I'm at my midline. My third critical point, 3 over 6, reduces to pi over 2. Pi over 2, I'm going to be at my maximum, because my third critical point's up here at my maximum. So at pi over 2, I'm up here at my maximum. My fourth critical point, 4 pi over 6, that actually reduces to 2 pi over 3. 2 pi over 3, we're sitting at about here. And that is going to be back at my midline. 2 pi over 3, we're sitting about there. And finally, we are going to be, actually it's a little bit tighter in here, I think. There we are. And finally, my fifth critical point is going to be at 5 pi over 6, which is, actually, no, I think I was right the first time. Sorry, we are looking about here. Because then my fifth critical point is going to be at 5 pi over 6, which is just less than pi, which is about here, and we're down back at my minimum. Okay, so there's my 5 critical points. I can connect the dots. This is a pretty skinny one, but we're going to talk about why that might be in just a second. All right, so something like that. That is going to be one cycle of this function. Okay. Now, if they ask for a second cycle, we could do that again, or a third, or a fourth. Okay, it all depends on what they ask for. Well, they haven't asked for anything, so we're just going to do one. But if you would like to do more than one, that is totally okay. You won't lose marks for that. But let's now kind of take a step back and see why this sketch makes sense when we're talking about our reflections. Okay, well, so let's kind of summarize our transformations. So my a value was negative 1.5. So this actually tells me two pieces of information. The fact that it's negative means it's reflected over the x, which we saw. Okay. And because it's greater than 1, is actually a vertical stretch by a factor of 1.5, because the original function only had an amplitude of 1, but this has an amplitude of 1.5, so it's been stretched vertically by about 1.5. Okay, which makes sense, right? We've been reflected over the x-axis, which is a vertical reflection, right? Because we're reflecting this way, right? And a vertical stretch up. Okay, well, what about my k value? K being 3 implies that this is a horizontal compression of 1 over 3, right? Because remember we deal with 1 over k value when we're describing these. So horizontal compression by a third, which again, this makes sense, right? The original would have been 0 to 2 pi, but we've cut that down by 3, and it is only 2 pi over 3. So this was horizontally compressed and squished in by a third. So it only covers a third of the horizontal distance that the original 2 pi would have been. All right, making sense so far. My d being pi over 6 implies a shift right of pi over 6, which we did. We've shifted from 0 over to the right by pi over 6. Good so far. And finally, c of 0.5 is a shift up of 0.5, right? Because my original midline should be at 0, but my midline was shifted up by 0.5. So all of our transformations, if we were to try and describe all of these things, still stand and make sense for our sketched out graph.